Hey there and welcome. Today, we're going to get down to the basics. The real basics of everything around us. We're talking about elements, compounds, and mixtures. We're going to break down exactly what makes each one different, so let's dive right in.
So, here's what we've got on tap. We're going to start with the absolute simplest stuff out there, the elements. Then, we'll see what happens when they combine chemically to make compounds. After that, we'll explore what it means when things are just physically mixed together. We'll even dig into the two different kinds of mixtures before we wrap it all up with a nice clear summary of the key differences.
All right, first up, elements. These are the most basic, fundamental building blocks of, well, everything. You can almost think of them as the primary colors that paint our entire universe. Okay, so what makes an element an element? The big idea here is that it's a pure substance. And why is it pure? Because it's made of only one single type of atom. You can't take an element like iron or oxygen and break it down into anything simpler using a normal chemical reaction. It's as fundamental as it gets.
So, to break it down a bit, every element is defined by its own special kind of atom. And while you might picture elements as being solid, like iron in a building or the carbon in a pencil, they can actually exist in any state. We breathe oxygen gas every second, and some, like mercury, are even liquid at room temperature.
Now here's something that might surprise you. Even though elements can be solids, liquids, or gases, check out this distribution. The vast majority of them, we're talking over 80%, are actually solids at room temperature. Only a tiny couple of them are liquids, which makes elements like bromine and mercury pretty unique.
Okay, so we've got our individual building blocks, our elements. But what happens when you start clicking them together? Well, that brings us right to our next category, compounds.
And this part is super important. A compound isn't just, a casual mix-up. It's a very specific chemical event. First, you need at least two different elements. Second, they have to combine chemically. That means they're forming actual bonds with each other. And third, and this is crucial, it always happens in a fixed ratio. It's like a strict chemical recipe you have to follow every time.
This is a perfect example of what we mean by a fixed ratio. Let's take carbon dioxide, CO2. Every single molecule of it in the universe is made of exactly one carbon atom bonded to exactly two oxygen atoms. If you change that recipe, say one carbon and one oxygen, it's not carbon dioxide anymore. It becomes a totally different substance.
And we're literally surrounded by compounds every day. Water is always H2O, two hydrogens, one oxygen. The methane gas in a stove is always CH4, one carbon, four hydrogens. It's this fixed chemical recipe that makes a compound a compound.
But what if you throw things together without a chemical reaction? Well, that's when you get our third category, mixtures. The big difference here is that the substances are just physically hanging out together. They're not chemically bonded at all.
This really puts it all side by side, which is super helpful. For a compound, think of it like baking a cake. You mix flour, eggs, and sugar, and they chemically change into something totally new. You can't just pick the eggs back out, right? But a mixture, that's more like a salad. The lettuce and tomatoes are in the same bowl, but they're still just lettuce and tomatoes. They're only physically combined.
So here's the official breakdown. In a mixture, you've got two or more things that are physically together, but there's no chemical bonding. And this is key, there's no fixed ratio. You can add a tiny pinch of salt to water or a whole spoonful. Either way, it's still just a saltwater mixture.
Okay, but we're not quite done with mixtures. Turns out they come in two main flavors. And it all just depends on how evenly everything is blended together. We call them uniform and non-uniform mixtures.
So, on one hand, you have a homogeneous mixture. That means it's uniform, the same all the way through. Think about the air you're breathing or a scoop of ice cream. You can't see the individual parts, can you? On the other hand, you've got a heterogeneous mixture. This one is non-uniform. Think about putting some pebbles in a glass of water or looking at a handful of different rocks. You can clearly see all the different pieces. They're mixed but not evenly.
All right, let's bring it all home. We've gone through elements, compounds, and mixtures. This final summary is going to help lock in the key differences between all three of them for good.
This table right here is basically your cheat sheet. An element, it's pure. It's not combined with anything else. A compound, that's where you get that chemical bond and that always fixed ratio like our good friend water, H2O. And a mixture, that's just a physical mashup with no fixed ratio required, like the air we breathe or a handful of rocks. Really, if you just remember the difference between chemically bonded and physically mixed, you've pretty much got it.
So I want to leave you with a little challenge. Just look around you, right now. wherever you happen to be. Based on what we've just talked about, can you spot one of each? Can you find an element, a compound, and a mixture? Once you start looking, you'll start to realize these building blocks are truly, truly everywhere.
Thanks for watching.